Module 2, Guiding Reflection Question number 1. If the circles in the 5 by 5 square in Module 1 were filled instead with 1 by 1 yard tiles, how many tiles would fill the space? What would the area of the space be? How would you write a formula for the area of a square, of any square, using S to represent the length of one side of the square? So here you see these yellow dots, which represent dots that you used in Module 1 to create squares. Now here we are instead replacing those dots with 1 yard by 1 yard tiles. So you see on the bottom left, each side of one of the tiles is 1 yard. So along one side of this larger square we have 5 tiles, so with each 1 yard in length, so that means we have 5 yards along the whole square. So we have a 5 yard by 5 yard larger square. And the question is, what are the number of 1 by 1 tiles that fill this space? Because that would represent the area of that space. And we could get those number of tiles that fill the space by adding up all the tiles. But that would be tedious. A quicker way would be to consider that multiplication is repeated addition. So we have, for example, 5 rows 5 times. 5 rows and 5 columns. We have 5 rows 5 times. 5 times 5 is 25. So 5 yards times 5 yards is 5 times 5 yards times yards. So that 5 times 5, remember, is 5 squared, where the exponent, the square, that small 2, tells us the number of times 5 is a repeated factor. The number of times the base is a repeated factor. So we can write 5 times 5 is 5 squared, yard squared, which is 25 square yards. So that the area of this space inside the larger square is 25 square yards. Now a formula for the area of a square, if we let S represent the length of one side of the square, so S stands for side, okay, then we could write S times S and simplify that as S squared. So the formula for the area of a square can be written as area, or just A for area, equals S squared.